Hi, first of all, thanks for looking at my assignment. I've decided to analyze the data sets and model um, the data using Python. I'm by no way a Python expert, but a great learning curve. So first of all, what I've done, I've uploaded my CSV file into my Google Drive, and from there, I'm just importing my file into a Panda dataset. So you can see here, um, mounting the device, I'm gonna have to authenticate. Let's check for authentication. Coming up. Okay, drive is mounted. Now I'm loading my dataset. Okay, and importing a few libraries here. All right, so all my data is here, and now is the right time to start to look at it and to evaluate it and have a quick check. So what I'm going to do first, I'm going to check for any missing value. You can see here, I'm going to check if there are some rows which have no values and drop them if needed, and print a few information about my data sets. Here we go. What you can see here, we have our features. The first four columns are the features. The last one is the target data. I can see the first rows looking okay. I can see that there is no data column without any data, no row either. I can see as well some information about the data set with the average, how many lines, standard deviation, mean, max, and so on and so forth. So now it's time to think about what I need to do. I have a couple of features. I have target values I need to find. That's a very typical regression model. We'll use two things. The first one is to use a couple of regression algorithm, starting up with linear regression. Next, I will do some lasso regression and look for the best alpha. And finally, I will test some decision tree on random forest and compare all of them. In order to compare all of them, I'm going to use the MSE, the mean square error, as the comparison of those models. But first of all, since I've had the first look at the data, I'm going to check at which of those features matters. So I'm going to calculate the correlation matrix of that data set and print it out. So that's what I'm doing here. I'm computing the correlation matrix, and you can see here that a couple of things stand out. We can see that V is one value which matters, and you can see in the matrix that basically P is the target value. It's not the features. So definitely AT and V have a much larger importance than the other ones, since they have a much larger coefficient ratio. So you can see as well AT here and PE, both of them looks like the most important features, but we'll get back to it later on. Now I'm starting to work on my data sets. So I'm going to cut my data sets into, first of all, features and target values, extracting the features. So I'm dropping the last column. Next, I'm cutting my data set of features into two, 80% for training and validation and 20% for final testing. So you can see here I'm extracting the test data set, and next I'm cutting my training data set into training and validation. So now I have basically three data sets, one for training, one for validation. Both of them will be used to tune the model, and the last one, testing, is going to give me the outputs on values which are unknown to the model, and check next the MSE on that final data sets. Next, I'm doing some data transformation, so I'm fitting and transforming the training data sets. I'm transforming only the validation as well as test, and I'm not touching at all the target values. So that's what we do here. Let's run that piece of code. The code is okay. So I'm going to do a couple of things now. I'm going to use linear regression, lasso, decision tree, and random forest. Let's check what's going on here. Okay, so let's go first with the linear regression. Very easy. And I can see here I build my model. I'm testing my model on my test dataset, and I have an MSE of 20, which given the scale of the target is pretty good. I'm using next a lasso regression model and initializing it and testing a couple of values for lasso alpha from 0.0.1 to 10, and I will output the best alpha value. The best alpha value here is 0.0.1, and the MSE for lasso is 20, very close to the previous one, and I have a list of features which matters. Next, I'm using a decision tree here. You can see decision tree 22 as the MSE. I use a random state as initialization, nothing special. And finally, I'm going to use the random forest here. And my random forest is giving me an MSE of 11 and features, the most important features being AT and V, which do confirm the coefficient metrics we had a little bit earlier on. So finally, if I compare all of them, it looks like the three models are very close by. Linear regression, lasso, and decision tree, and random forest is giving a better result since it has the lower MSE. So it looks like we've seen in the lessons, like linear regression gives a very good first information, and that we can tune using more complex algorithm. I hope you enjoyed, and thanks for your time and comments. Bye bye.